Okay, kids, Charlie Abuso here. We're going to do something a little different. We're going to go through the notes one page at a time. That way you can watch what you need to and not have to watch a whole long show if you don't need to. The types of bonds that we're going to see. Ionic bonds form when a metal and a nonmetal bond together. They transfer, F-E-R, electrons. They transfer electrons. Covalent bonds form when a nonmetal and another nonmetal bond. They share electrons. It's a major difference. Now, how do you tell the difference? Ionics start with a metal. Covalents start with a nonmetal. In a metallic bond, this is just a hunk of metal or an alloy, which is metals melted together. Only a hunk of metal. All right, this doesn't happen. It's not with, this is just one kind of metal or metals that are melted together. This is a little weird. Intermolecular, this is molecule to molecule or molecule to atoms. All right, this is between the particles. This is not inside of a bond. This is between particles. A couple of vocabulary words to help us through this. The outermost electrons are called the valence electrons. They're in the valence orbital. All right, the outermost electron orbital is called the valence orbital. Bonds always form when atoms or ions end up with full outer orbitals. By transferring electrons, they end up with full outer orbitals, or by sharing electrons, they end up with full outer orbitals. Now, to draw a Lewis dot diagram, the dots represent electrons. We've already seen that in the homeworks. The Lewis dot diagrams only show the valence electrons, not the inner electrons. They do not show the inside ones. They only show the outside ones. For the electron orbitals, the first orbital is very small. It only holds 2 electrons total. The second orbital is bigger, and it holds up to 8 electrons. Now, we're going to start with this chart, and then we're going to keep going, although we're going to stop at the end of this page, and then you can pick it up where you need to. The Lewis dot diagram for hydrogen has just one dot. Now, hydrogen is a nonmetal, but it's sort of attached to group 1. But it's not really in group 1. It's not a metal, it's not an alkali metal, but it's in group 1 kind of, because it can make stuff called acids. An acid is a hydrogen ion. Now, this is not normally formed with a metal and a nonmetal. It would be hydrogen and chlorine, or hydrogen and fluorine, hydrogen and another nonmetal, generally, okay? So the hydrogen would look like this. It would lose its electron and become a positive one. But this is a really weird atom. Most nonmetals, no other nonmetals, become positive ions. But there's a whole separate branch of chemistry called acids, because this is what it does. Now, helium has 2 electrons. It doesn't matter where you put them. I put them on the right. You could put them on the top or the left or the bottom, but they're going to be a pair. Electrons are more stable when they're paired up. And helium doesn't make ions in any normal way. I mean, you could force an electron off of it. There is a first ionization energy, but it's extremely high. Helium does not make ions. It's a noble gas. Now, lithium. Lithium has a 2-1 electron configuration. Now, this is tricky. There's only 3 electrons, but we only show 1 dot because we only show the valence electrons. Now, when lithium makes an ion, it becomes a +1. And so, therefore, it loses its outer orbital electron and becomes 2-0. But we only show the valence orbital. And the metals, when they become cations, have empty valence electron orbitals. Beryllium, 2-2. That means beryllium has 2 dots. I'm going to put them on top this time. It doesn't matter where you put them, top, bottom, left, or right, but they have to be in a pair. It's more stable. Now, when beryllium becomes a cation, it's in group 2, it's going to lose 2 electrons. It's going to become Be positive 2. And when we show that as a Lewis dot diagram, we say Be, which used to have 2 dots, now has no dots in its outermost orbital. It really is just 2-0, and we show it this way as Be in brackets.